Today we're looking at note 6-4, square root equations. So if I ask you to solve this square root equation here, or any square root equation, what you're going to do first is isolate the radical. Okay, so here we've got square root of x minus 5 equals negative 2. So we need to get rid of this minus 5 because we want the radical all by itself. So the inverse of subtraction is addition. So add 5 to both sides, so we get square root of x equals 3. And then once the square root is all by itself, you're going to square both sides. So square the left, square the right. The square root and the square are inverses, so they cancel each other out. We get x equals 9. So we are going to box this solution and call it our answer, but you always need to check it. So check your solution, because we will, as we're working with square root equations, we will be getting some extraneous answers. So we always need to go back and plug that into the original and make sure it works. So let's go ahead and do that off to the right here to save some space. So we had square root of x, well x is now, we're saying it's 9, minus 5 should equal negative 2. Well, square root of 9 is 3, and 3 minus 5, does it equal negative 2? Yes, it does, so we're good to go. Okay. Move on to the next problem. So square root 2x minus 1, and then plus 3 equals 12. Okay, again, like before, our first step is to isolate the radical, so we need to get rid of the plus 3 by subtracting 3 from each side. So we get square root 2x minus 1 equals 9. Now that the square root is all by itself, we can go ahead and square both sides. So we get 2x minus 1 equals 81. And then it just becomes an algebra 1 problem. So add 1 both sides. You should get 2x equals 82. Okay, when you add 1, add 1. And then you're going to divide by 2 on both sides. Okay, and that's going to give you x equals 41. So again, we're going to box it because we're going to assume it's right for now, but we need to go back and make sure. So going back to the original problem, we would have 2, where we see x, we'd plug in 41, minus 1, plus 3 out of the radical, and then equals 12. So let's check it. So this would be square root of 82 minus 1 plus 3 should equal 12. So square root of, that'll be 81. 82 minus 1 is 81, plus 3 equals 12. So that'd be 9 plus 3 equals 12, and that's definitely true. 12 equals 12, we're good to go. Okay, so let us do another problem. Another page here. Number 3. Okay, 2 square root 3x plus 1 plus 6 equals 16. So again, isolate that radical first and foremost. So in this case, I need to get rid of the 2 out here and the plus 6 out here because I want this radical all by itself and what's inside it. So I need to get rid of the plus 6 first by minus 6 minus 6. So I get 2 radical 3x plus 1 equals 10. Then divide both sides by 2. Okay, so we get square root 3x plus 1 equals 5. Now I can square each side. Okay, so I get 3x plus 1 equals 25. Then subtract 1 from both sides. I get 3x equals 24. Divide by 3, I get x equals 8. Okay, and then just like before, you always need to, I'm going to box it, but I'm also going to check that it truly is a solution. So I would have 2, 3, where I see x, I'm plugging in 8, plus 1, plus 6 equals 16. So that'd be 2, that'd be 24 plus 1, plus 6 equals 16, so that'd be 2 square root 25 plus 6 equals 16, so square root of 25 is 5. So 2 times 5 plus 6, does it equal 16? Yes, because 2 times 5 is 10, and 10 plus 6 definitely equals 16. 16 equals 16, it's true, it worked. Okay, so I do have a word problem to do with you real quick, but I want to talk about real quick what is going on here when you're solving. So when we get to this step here where the square root is isolated, before I square both sides, so when I want you to come up here and think about, I had square root of 3x plus 1, let me erase that, I made it a little too big, equals 5. So that was before I squared both sides. So anytime you have a square root problem like this here, what's happening is I've got a square root equal to a number, a constant. If you think about the graphs of these two, so a square root graph, you know, looks like this. Okay, no matter where it is on the coordinate grid, it looks like that, or it could be upside down, yes, I know, but it looks something like this. This kind of graph here is a line. It's a single number that's a line. That would be something like this, straight across. So what we're finding when we're solving is the intersection of those two things. So that is why when you solve these, you will sometimes get extraneous solutions, because think, if I had a square root that started here, and then say the constant was something that was below it, will those two lines, or excuse me, will those two graphs ever intersect? These two will not. No, this one's getting higher and higher and higher, and this one's just staying exactly where it's at. So here in this case, they don't cross, so you would have no solution or something that would come out extraneous. But here on this one, notice the constant and the square root graph, they crossed. So that's essentially what we're finding when we're solving here, where they cross. Okay, so let us do a word problem. Here it is. The function t of h equals square root h divided by 16 identifies the time in seconds that it takes an object to fall a distance of h feet. So part A, I want you to find the time it takes an object to fall 48 feet. And I want you to round to the nearest hundredth. Okay, so find the time it takes an object to fall 48 feet. So the function t of h equals square root of h divided by 16 identifies the time in seconds it takes an object to fall a distance of h feet. So h represents the feet. So then the t of h represents time. So t of h equals square root h divided by 16. Well, the distance that they're giving us, the h, the feet, is 48. So 48 divided by 16, okay, and then you're going to take the square root of that. So when you take 48 and divide it by 16, that's 3. So we have the square root of 3, which then it told us to round. So the square root of 3 is 1.73205 da 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 da. So, but it wants us to round to the nearest hundredth. That means 2 places. So 1.73. So approximately 1.73, well, 1.73 what? This is time, and it's saying time in seconds. So 1.73 seconds is how long it will take for the object to fall 48 feet. Okay, so part B. Part B, I want you to find the distance an object has fallen after 5 seconds. Okay, so find the distance. Now I need to find the distance after the object has fallen 5 seconds. So in this case, it's giving us the t, the time, so we need to say 5 equals square root of h divided by 16. Well, we need to find the distance, the h, okay? So here, to get h by itself, we're solving a square root equation. Okay, we need to square both sides because the square root's already by itself. It's okay that it's on the right. It's by itself, so square both sides. We get 25 equals h divided by 16. So then to get h completely by itself, multiply each side by 16. So 16 times 25 is 400. 400 equals h. But what units do I use? So distance in h is feet. So 400 feet is how far the object has fallen after 5 seconds.